Hello everyone. In this lecture we are going to discuss about the transform analysis of a linear time invariant system. Transform analysis of a linear time invariant system. Okay, so before that we have a small discussion about what are the linear time invariant systems. So what are invariant system? Time invariant system. Time invariant system are simply those systems which remain fixed over the time. Okay, the time invariant systems is if the behavior and characteristics of the system are fixed over time. Okay, टाइम के साथ साथ वो फिक्स रहते हैं, means there is no change. A system is time invariant if a time shift in the input signal results in an identical time shift in the output signal. Okay, time shift, let's write down time shift in input signal, okay, results in time shift of output signal all right. For example, if a time shift in a time invariant system, it should produce the output as y t minus t naught, okay, as an output when the input is being given as x t minus t naught. This is a simple example of this. All right, so this is simply the time invariant system. Next, let's discuss about some properties of the linear time invariant continuous time system, in which let's first discuss about linear time systems with and without memory. LTI, linear time invariant systems with and without memory. Okay, this is the first one. So the output yt of a memory less system depends only on the present input. All right, the output yt of a memory less system, all right, memory less system depends only on the present output. Sorry, it was the output, present input. Okay, xt. Now if the system is linear time invariant, then the relationship between yt and xt for a memory less system should be yt should be equals to cxt, where c is simply the constant. So since the output of a continuous time system can be written as yt should be equals to minus infinity to infinity h tau x t minus tau d tau. Okay, so the corresponding impulse response is ht is equals to c delta t. Okay, so thus the continuous time system is memoryless if and only if this condition is going to get fulfilled. All right. Now second property is causality. Of LTI system. Okay, so the output of a continuous time system, as was written earlier, output of a continuous time system simply yt is equals to minus infinity to infinity h tau x t minus tau d tau. Okay, so since the impulse response h tau is equals to 0, impulse response h tau is equals to 0 for tau less than 0 for a causal continuous time system. Okay, just remember that for a causal continuous time signal. Okay, so the output, इसका output क्या आएगा आपका? इसका output simply आपका हो जाएगा from 0 to infinity h tau x t minus tau d tau. Okay. Now third property in this is stability. Stability for LTI system, linear time invariant systems. So the continuous time system is bounded input, bounded output stable if and only if the impulse response is absolutely integrable. All right, is absolutely integrable, that is minus infinity to infinity h tau d tau should be less than infinity. Okay, so this is the third property of linear time invariant system. Now the next property of linear time invariant system is invertible NY-LTI system. Okay, what are invertible linear time invariant system? Our system is invertible if its input xt can be recovered from its output yt is equals to xt dot ht. Okay, so a cascade of linear time invariant system having impulse response ht with a linear time invariant system having impulse response of gt is equals to h inverse of t. It is simply shown in the figure as you can see that. Let's draw the figure as ht. Okay, this is simply xt, this is yt, this is become gt, which is equals to h inverse of t. Okay, and then it will give again xt. So this is simply the cascade connection of linear time invariant system and its inverse. All right, so the process of recovering xt from xt dot ht is called deconvolution. What is it called? Deconvolution. Okay, because it is a reverse process of the convolution operation. All right, so the overall impulse response of invertible system, this is simply the overall impulse response of invertible system shown in figure. This is here it is shown is simply the convolution of ht and gt. All right, so it is required that the output of a invertible system is equivalent to the output of the invertible system. This is the invertible system, so the output of the invertible system should be equals to xt, which can be written as xt dot ht inverse. Okay, so this is a process going on over here which is giving you again the xt. So simply this we got at the output. All right, so up till now we have discussed the properties of a linear time invariant system for the continuous time signal. So let's discuss one or two points about the linear time invariant system, linear time invariant discrete time system. All right, discrete time systems. All right, so linear time invariant system have significant signal processing application. Okay, and hence it is of interest to study properties of such system. So just look into that. it let's see input output relationship. Input output relationship. Okay, so just for an arbitrary sequence xn, this is a discrete time sequence, can be expressed as a weighted linear combination of unit sample sequence. It can be expressed, xn can be expressed as a weighted linear combination of unit samples sequence given by, simply given by what, xn is equals to k is equals to minus infinity to infinity xk, simply small k is there, delta n minus k. You must have studied this in the discrete time system. So now the discrete time system response, its response is discrete time system response. Let's write down discrete time system response, yn response is given by, yn is simply is equals to what, r response of, this should be yn is equals to r of xn. Okay, and this r is also, this can be written as k is equals to minus infinity to infinity xk delta n minus k. Okay, so from the principle of superposition, the above equation, this can be written as yn, we can write this equation as yn from the principle of superposition. Must remember that we can write this from minus infinity to infinity xk response of delta n minus k. Okay, so let the response of the system due to input be, just suppose that let the response of a system due to input delta n minus k be h k n. Okay, just suppose that this is the response, that is h k n is equals to response of delta n minus k. So the system response yn for an arbitrary input is simply given by the system response yn for any arbitrary input xn is simply given by, yn is given by from k is equals to minus infinity to infinity xk hk, this should be hkn. Okay, now since delta n minus k is a shifted version of delta n, okay, so the response hkn is the time shifted version of impulse response hn. Okay, is simply the shifted version of Sn. So since the operator is time invariant, hence hkn, this should be equals to hn minus k. So thus we can write down this as yn, this should be equals to from k is equals to minus infinity to infinity xk h n minus k. Okay, so the above equation for yn is commonly called convolution sum. The above equation, this one, is simply called as convolution sum, and it is represented as yn should be represented as xn convolution of hn. This star simply represents the convolution. Okay, so the discrete time convolution operates on the two sequences xn and hn to produce a third sequence yn. Okay, this work on two sequences xn and hn to represent yn. Okay, so now the stability and causality for a linear time invariant system in terms of impulse response. Okay, in terms of impulse response for a discrete time system, we should continue on the next one. All right, so this is up to now, just go through that. Thank you.